Good evening everyone. In the last class we had discussed a few conceptual problems. In continuation of that, let us start with a good problem. Look at now. We have a conducting thin spherical shell of radius r. Charge q, which is of positive nature, put on this shell. And same point charge, in fact positive point charge, is placed here inside this shell at a distance of 0.5 r here q, and a third point charge which is placed at a distance of 2 r and its value is amount is 2q, which is also of positive nature. Now we have to find number 1, potential of the cell. And when this cell is earthed, then we have to find how much charge will flow from earthed cell to the earth. Number 2, if this cell is earthed, then how much charge will flow from cell to the earth, cell to the earth. Now firstly we have to find potential of the shell. Mind you, the cell is conducting. Now we have to think firstly charges separately. So if we think of this plus q, then we all know distribution of charge on this cell or any surface, that is density of the charge on the surface, or you may call it surface charge density, sigma, is proportional to 1 over r. Look at every one of the infinitesimal area on the cell is at the same distance from the center. So we call it same radius of curvature. So charge will distribute uniformly. Okay, no problem. Now we think the charge which is placed inside, that is at 0.5 r from the center. So obviously this charge induced here on the inner surface minus q. However, distribution of the charges, induced charges in fact, not uniform, because charge q is not placed at the center, that is why. So here more charges, more negative charges and less negative charge as distance increases. Now, and amount will be what? Plus q, and plus q charge will induce on the outer surface. Now this charge will distribute uniformly. It's the plus q. Now if we consider these two charges, then charges on the outer surface is 2q. Now look at the third charge, 2q. So this is outside charges separately. Separately we have to think plus 2q. So some negative charges here and some positive charges there, and charge will not distributed. In fact, induced charge is not distributed uniformly, non-uniform distribution. Now we merge these charges together, induced by this plus q charges on that shell plus q, and induced by this, say in the nearby minus and the outer side plus. So these are the charges. Now we have to find the potential of this shell. Then what is the definition of potential? If we bring a unit positive charge from infinity to that cell, then we have to do work against the field force of what? We have three charges, plus q inside, plus q on the surface, and 2q outside. These charges will produce field. Let us see in which manner. So here we are going to use shielding concept. This charges plus q induces the charge inside it, which is not distributed uniformly because the charge is not placed at the center. So the lines of forces emerges from this plus q will terminate on the inner surface, will not go outside. So look at here, but perpendicularly to the surface. Look at here, perpendicularly, terminate there. However, here electric lines of forces are less dense but perpendicularly. So no line will emerge outside of this cell. It is known as shielding effect. To find the potential, what we have to do? We have to bring a unit positive charge from infinity to that surface of the cell. So this field will not contribute anything. Keep in mind. So now think about that plus q and plus 2q. So these two charges produce field. But what about? Are these two charges produce field inside? Again answer is no. Reason? Due to shielding effect. So whatever the lines of force here and there, so these line of forces by plus q or plus 2q or by this plus q came through induction of the inner charges. Do not pierce the surface and go inside the cell. No, no way at all. This is known as shielding effect for the outside charges as well. Keep in mind. Now, but it is very clear now. This charge will not produce anything outside charge, or even the charge on the surface will not produce anything inside it. But we have to find the potential of the shell at any point on the surface. Now, we ignore this charge because its field will not contribute anything to find the potential of the shell. But still, a twist in the problem. What is the twist? Twist is that now if we combine all these charges, the charges are not distributed uniformly on the outer shell. In fact, outer surface of the shell. And we have to find the potential of the surface. However, this is the conductor. Potential at any point will be same. But how one can find, taking a point on the shell, in fact, on the surface of the shell? No way at all. If so, then very clumsy, very cumbersome mathematics will involve. No, still a way. Because if you bring the charges, unit positive charge from, in fact, from infinity to this shell, that work is over and you find the work. No way at all. So, take the charges from infinity to the center of the shell. So, one obvious question is that, sir, once charge came inside, so field of this will going to interact. No, just I have told you that. Ignore this one. Because of plus q and 2q will not produce any field inside it. And we have to find the work done against these two charges. In fact, against the field of these two charges. That is why. So, we do not mingle the plus q charges, and then you will be in dilemma. You will confuse. So, keep in mind, no contribution of this. So, here there is no field of these two charges. So, no work to do to bring the charges, in fact, unit positive charges, surface to the center. That is why. So, no work is done. So, we have to find the potential due to this plus q and this plus 2q charges at the center, and the work will be over. So, take any point. So, potential on the surface is due to this plus 2 charges on the surface and this plus 2 charge which is at a distance 2r from the center. That is very easy to find. So, this is the 2q divided by 4 pi epsilon naught r plus 2q divided by 4 pi epsilon naught 2r. So, take 2q divided by 4 pi epsilon naught r as a common. So, is the 1 here 1 by 2. Now, this is 3 by 2, 2 will cancel out, 3 left, 3q over 4 pi epsilon naught r, and that is the answer of first question, because we have to find the potential of the shell. Okay. Now, the second question is that if we earthed it, second question, if we earthed it, look at here now. It's plus q is the center, radius r, plus q 0.5 r and the 2r. We take anywhere, say here. So 2r, 2q charges. Now this cell is earthed. Look at here. Before earthing, how much charge on this shell? Plus q due to induction of the inner charge, plus q already given on the shell, and this plus 2q charges induces negative charges in front and as much positive charges on the rear end. So if we sum up, comes out to be 0, because in sum of the induced charges always comes out to be 0. We ignored induced charge on the inner surface because it is bound charge which cannot flow after earthing. Please keep in mind. Now, what will be after earthing? We have to find. So what charges will left on this cell after earthing? We do not know. Then we have to find charge on this cell after earthing. We do not know right now. So take it, say plus q. Take it as q, whatever plus or minus, we will judge later on. But we all know after earthing, shell potential reduces to 0, or you may call in another words, potential of the shell is equal to potential of the earth, and earth's potential is assumed to be 0 volt. So after earthing, the cell potential becomes 0. Okay, now we have to find the potential of this cell at any point P. We have to find Vp and then equate it to 0 to find the charge on the cell Q after earthing. So again the same funda, because this will induce, okay, after that, that's fine, all this induces total altogether. However, charge is not distributed uniformly in initial case, in the first case also. So this charge is q, so this is the net charge. Due to induction, already it has plus q and induction by 2q, all together the q. Fine. Same funda. Potential. We have to bring a unit positive charge from infinity to the surface. Then we have to do work. And this work is known as potential because we are carrying unit positive charge. By definition of potential. That's fine. Okay. So again, field of this inner charge, nothing to do to carry unit positive charge from infinity to the surface. So ignore this one. Again the same funda here. Find the potential. So potential due to this q over 4 pi epsilon naught r plus here 2q 4 pi epsilon naught into 2r. So as it is earth potential is taken to be 0 volt, so this is 0. So this implies q is equal to minus q. Q is equal to minus q. The final charge after earthing on the shell is minus q. Minus q. Now we have to find charges is flown from earth shell to the earth. I. Let us find. charges is flown from earth shell to the earth is equal to Q initial minus Q final. Q initial 2Q minus of Q, this is equal to 3Q. So 3Q charge is flown from earth shell to the earth. That's completes the second one. This is a very nice problem because we have used what? Shielding effect. This is the beauty of shielding effect. Now, let us take another problem. Now we take another very nice problem on the method of image. Let us start now. We have thin spherical shell, so radius r, and a point charge, in fact positive point charge is placed at a distance a from the center Q. We have to find potential and force of interaction between this point charge and this cell at a point, say here, distance c from that point charge at point P. We have to find the potential at point P and also the force of interaction between this point charge and the sphere. To do this, firstly, we try to understand method of image. If this will be clear, then we will solve this problem quite easily. Look at now. So we take two point charges, say Q1 and Q2. Say it is origin 0, 0, 0 and is at a distance, say D here. So coordinate will be D0, 0. Now we try to find the equipotential surface due to these 2 point charges Q1 and Q2. So take here, say point here, say P. Its coordinates taken as x, y, z in space. We have to find the potential of Q1 and Q2 at point B. So we all know what? Vp Q1 over 4 pi epsilon naught. Space is assumed to be vacuum. These 2 point charges are placed in vacuum. Okay. So Q1 4 pi epsilon So this is R1. So this is square root of x minus 0 whole square plus y minus 0 whole square plus z minus 0 whole square plus q2 over 4 pi epsilon naught x minus d whole square plus y minus 0 whole square plus z minus 0 whole square root. But we want an equipotential surface such that at every one of the point potential is 0. Now look at here, positive, 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 q1, q2, and we equate it to 0. It is possible only when if these 2 point charges are of opposite nature. However, we had discussed in the earlier videos, we talk about nature, but we are saying, we are writing, we are taking negative, positive. Keep in mind, charges are neither negative nor positive, but still we use mathematical operation less than or equal to or greater than 0 like that. So obviously these two are of opposite nature, then only then these two terms, in fact sum of these two terms comes out to be 0. So for this we take q1 as a positive, you may take negative, no problem at all. Definitely q2 is of negative nature. So if we manipulate it, then we will get an equation of sphere. Like here, if we arranged, we have to do with algebra here, and to get like that here, x minus something whole square plus y minus something whole square plus z minus something whole square is equal to some positive number whole square. So this represents an equation of sphere. Now we have to equate it with the standard equation of the sphere. What is the standard equation of the sphere? X minus alpha whole square, y minus beta whole square, z minus gamma whole square is equal to d square. We have to compare these two equations and we will get what? Just I am going to write it down. So this is the sphere. So somehow like that here. This is the spheric basis. So what is the, here say somehow center of the sphere, say here. So this, from equating we will get the coordinate of center. So if we take it, say S, then S is equal to, after doing these things, okay, it is up to you how can you manage these things. If you are unable to manage these things, you may comment in the comment box. So we will take, however you are able to do that. So S is equal to q1 square d over q1 square minus q2 square. Radius r here, say it takes radius say r. So r is comes out to be minus q1 q2 d over q1 square minus q2 square. And here, look at here, this is the center and this is the q2, this distance, say this distance is say b. So this comes out to be q2 square d over q1 square minus q2 square. But we are interested these things in terms of say here S q1 and r. Again, by doing some manipulation we may get quite easily. So here we will get q2 is equal to minus q1 r by s. R by s, and b is equal to r square by s, quite easily. So what we are going to do with these results in case of image method? Look at here, we had got these results by taking potential of the sphere is 0. You might take anything, but we are interested in such a way that the potential becomes 0. So only then we are in a position to get these results. Now just going to manipulate this result. Look at now here. So suppose we bring a conducting spherical shell in place of this, and we want the potential of this cell is 0. How is it possible? Look at now. So this is the outside charges, induces some charges on that, For a while we remove this q2, and we have to find the potential at the center, or in fact at the sphere, at any point of the surface of the sphere. Very clumsy, very cumbersome. So alternatively we find the potential at the center, because it is a shell, conducting shell. So at every one of the point potential are same. So only of this q1 charges potential there, and this is the potential of the shell. No way to find the potential at any point on the surface, because the non-uniform distribution of the induced charges due to q1. We had already removed q2. Just we overlap this same equipotential surface of 0 volt by a metallic shell, conducting shell. How is it possible to be 0, but still this time is q1 like that? So we have to put some charges on this shell. What charges we have to put to get the 0 potential? Look at, if this is the q2 and this is the q1, cell potential becomes 0, and we got that. So we have to put that much charge Q2 minus Q1 R over S on this metallic shell such that its potential becomes 0. Just we have used the concept Q1, Q2. No, the potential of the shell becomes 0. And as the case here, that's fantastic. So this is called image method. Means there is no Q2 point charges here, only the Q1 charge is here. Make the potential of this shell 0. So we have to put some charges there. Or in fact bring the charge Q2 or take charge Q2 like that, minus Q1 R over S or R by S. Then no need to find the charges or no need to put the charge on the sphere. So this is not looking charges. So this is known as image charges of this Q1. Now problem becomes too easy to find. Very simple. But once you know the image method, otherwise it is very clumsy, very cumbersome. You may try another method. So this is the concept of image method. Just we are going to use this to find the potential here and then force of interaction between this sphere and that point charge Q. Now let us. So this is the concept now we are going to use. So we have to mainly use these two results like that here. Look at surface. Very simple problem. Now it becomes very simple. So what charges induces on that? Very difficult to find the induced charges because some minus and some plus. We have to find the potential at point P. So do not worry about that now, because no matters how much charge is developed due to induction on that cell, negative, positive. So bring what? An image charge. What we had discussed, just image charge. Where you have to put? So we know B, R square over distance of the point charge from the center. Here is already A, not S. So here we have to put image charges Q2. Now question is that why we put inside, why not outside? Again a twist remains. Things that if we put these charges outside the sphere, then the concept of image method came from Poisson's law. So no way to use Poisson's theory. That is why. However, we are not going to enlarge on the Poisson's theory. So definitely this image charge must be inside the sphere, or you may say alternatively the region in which you are interested to find the potential, this image charge cannot lie on that side. Again, something must be from some theory. So it is Poisson's theory. But for the examination point of view or solving the problem, you may memorize like that the region in which we are interested to find the potential, we cannot put image charges on that region. So that is why it must be always inside the sphere. That is why. Okay, so Q2 is here, but Q2 is of opposite nature. So Q is already taken as a positive nature, the Q2 must be negative. Why? Because we had seen earlier potential to be 0. Only when Q1, Q2 were of opposite nature. That is why. So no matters here, Q2 is known, Q is already known. The Q2 is what? The Q2 all known, minus R over S. Here S is A. S is A. A Q is there. This is Q2. And the B here. So this is the center. So this is B. So what is B? The B is equal to R square over A. Now everything is quite easy now to find Vp. So this due to this Q and this is Q2. No matters, do not think over that, how much charge is induced on the surface. Very simple. Once you know, keep in mind. So here Vp comes out to be, look at now. So this is say C. So Q over 4 pi epsilon naught C plus Q2. Q2 is here, look at here, Q2 minus R over A Q over 4 pi epsilon naught. But the distance of this Q2 from here, so this is say up to A, we have to subtract B. So this one plus C. So here A minus B plus C. Look at now. So here Q over 4 pi epsilon naught. Take it out common. So here 1 over C minus R over A. R over A. Here A is already A. B in terms of known, R square over A. R square over A plus C. So again simplify little bit more, 1 over C minus, this is A square, AC is cancelled out here, R over A square minus R square plus A into C, and that's your answer. Looks very simple. Now the force of interaction between this Q and this cell means charge on this cell. But the charge on this cell is supposed to be Q2. Again, image method. Again, image method. So, force of interaction now. Right here, force of interaction. Force of interaction is equal to Q2 minus R over A into Q divided by 4 pi epsilon naught. This is the distance between these two. This is A minus B. A minus B whole square. So this is equal to A. A is A, B. B here R square over A. Now we have to simplify. Force of interaction comes out to be minus here Q square R over A whole over 4 pi epsilon naught here A square minus R square whole square over A square. So here one of the A is cancelled, A goes in the numerator, this comes out to be here Q square R A over 4 pi epsilon naught A square minus R square whole square. So your negative sign shows force is of attractive in nature. Okay. Now we have to find the magnitude of the force of attraction, which is of attractive in nature. So therefore magnitude is equal to Q square A over 4 pi epsilon naught A square minus R square whole square. So in study class we have taken two problems, one from shielding effect, another from method of image. However, we had discussed in a length. I think you will enjoy these two problems. In the next class, we will meet with again with very nice problem on this series of conceptual problems. Okay, thank you.